watching foreign movies, which is cool. It can tell you what shows you want to watch. You can inject advertisements in the right place, so really useful. And then obviously smart devices. So we all know about Siri and Google as well, and even our own Alexa. So you can talk to these devices and ask, what's for dinner? Give me a recipe. And that's very, very useful. So why does this actually matter? There are a lot of things in the world today that we cannot do at scale. Programmers cannot write that code because it's too complicated. And so GenAI kind of helps with that. But it can also generate new content, new ideas. And to Pinky's point, this is powered by something called a large language model, and or even just foundation models, which we'll get to in a bit. And we can see some of the use cases and things that you can do with this, including new experiences, productivity gains. So you can ask it to validate an email or write an email, or here's a bunch of data and tell me, do you see patterns with this insight that you can do? And then it's really good for creativity as well, help you write a story. One of my questions, good morning, is why now? Why has GenAI kind of exploded today? Anybody online what's possible with artificial intelligence and machine learning? But yes, you're right, very good for productivity. But why has GenAI taken off today? Why did it not happen 10 years ago or 20 years ago? Why is generative artificial intelligence so big now?
I think it's because of technology's changes each and every time. So
someone in the audience said it's because technology changes every single time. Mandy said, I missed that, enhancements of something, hardware, I think. Can't see the chat again. You're going to have to come off mute now. 25 zettabytes of data every single year. And that is a lot. That's like, if you had to put them on a hard drive, and the hard drive is like 1 centimeter big, and you stack it, and every hard drive is 1 terabyte, that is the height of Table Mountain 2.3 million times over. That's how much data that is. And so everybody's producing a lot of digital data every day, and that gives us data that we can use to train a model. But we also have access to compute that we've never had before. So really powerful GPUs, but we also have access to the cloud. So previously, if you had to do this, you would have to go and buy a server, you'd have to plug it in, you'd have to power it. That is a lot of money. Today, you can take a credit card, and you can go on the internet, and you can get access to AWS or other cloud providers, and get access to a large amount of compute, the same amount of compute that Master's JPL uses, that Standard Bank uses, you as an individual can go get access to. And if you combine that with the world's data, you can train these models in a way that you've never ever been able to do before. Does that make sense? So how do these models actually work? Well, when you type into the model, it's that the word is man. And so the model will then go, okay, that's one small step for man, but what comes next? And so the model will look at all the different words that are a possibility and figure out the next best word. So one giant leap for mankind. And so this prediction is not so much about what did Neil Armstrong say when he got the moon. It is complete the sentence. There is one small step forward, and based on all the data it's seen on the internet, the word man is the highest probability. And so it's a prediction machine. It's not actually very smart. It's just predicting the next word in a sequence. And so when we think about machine learning, where did this kind of start? So it started more than like 2,000 years ago. Most people don't realize that. Most people think machine learning has been around for like only a few years. But the Greeks, they tried to build humanoid machines more than 2,000 years ago, and they tried to build machines that mimic humans. Again, okay, I don't know what's going on. Over the last 2,000 years, we've been trying really hard to mimic how humans think. And really in the 60s, 50s or so, with binary processing and modern digital computers, did we look at statistical ways to mimic the way humans think, but also look at how do we classify stuff. and not us teaching the computer, not us coding the computer to classify stuff, but stuff called machine learning. So while artificial intelligence is kind of this bigger idea that encompasses things like programming and statistics, machine learning really focuses on statistical analysis of data. And so the computer itself can learn how to do those things on its own. And one of those things is something we call a neural network, which we'll talk about in a bit. But there's more than just neural networks. There's graphs, there's things that like mimic animals like ant colonies or particles. But in one specific type of machine learning is called a neural network. And this neural network, we've kind of started really small and then we grew it to really, really big neural networks. And those big neural networks we call deep learning. And so we have artificial intelligence as this superset. So think about it as animals. And then inside animals you get like the, mammal species. And then inside mammals you get humans. It's the same. So artificial intelligence is everything. And then inside artificial intelligence we got machine learning. And inside machine learning we have deep learning. And inside deep learning we now have something called generative artificial intelligence. And generative artificial intelligence uses a very special type of neural network, which we'll get to, called the transformer. And you don't need to know any of this stuff to use greater than another number, we generate a number. So if you think about your human brain, input comes in from all your senses, that hits a neuron. If that input is greater than some value, that neuron fires to the next neuron. And so we copied how the brain works. It's a mathematical representation. You don't need to understand how this works, but mathematically, you can see on the picture, if you want to see if something is a dog or a cat, we plot on an invisible graph all the dogs and all the cats. What makes a cat a cat? Well, the cat has retractable nails. That's something you can do. The cat meows. That's something you can classify, right? And so you put this on a graph. And all the neural network is trying to do is draw a line that says anything below this line is a cat. Anything above the line is a dog. And so it's trying to find that pattern. And when I showed you earlier the words, one small step for man, it's trying to take one small step, draw a graph, and see what the next word is in that graph. It's actually that simple. And so when this paper came out, the problem with this is you actually need a wavy line or a straight line. And so they called it the winter of AI for two reasons. One, people thought this approach was not going to work. And also, we didn't have the compute power. Fast forward to the 2000s, we now have the compute power and the data. And all of a sudden, artificial intelligence is the next big thing. And that's just because of that. And while this neuron, this perceptron, is very, very simple, it's now evolved into something we call the transformer. And this paper was created by Google Brain, and the transformer is the fundamental technique, is a parameter. And so in this neural network, there are only 4 parameters with 4 input parameters, so that's 8. And then an output, so that's 9. This neural network here is a 9-parameter. The new ones are hundreds of billions of parameters. They have more neurons virtually than we have in our human brain. Yet as humans, we are still smarter than these things. So there's a lot of room for improvement. How do we optimize it? How do we make it better? How do we make it faster? How do we make it use less power? Because in our brain, we use less than 0.5 watts of power.
Wow.
Yet these things, they use a lot of power. You can power many houses. And so how do we make these more efficient and better at what they do? Okay, so the transformer was the paper that kind of launched everything. The paper was called Attention is All You Need. And the transformer looks something like this. It has an encoder. So you take all the inputs, all the text that you read, book, that is decoding. That's all it really is. These words, they like seem fancy, that it's really, really simple. So think of the encoder as something that summarizes something, and the decoder as something that writes it all out. So when you say to the large language model, summarize my email, that's the encoder making it small. If you say, write me a story, that's the decoder. And so we have different types of these models. Some are made of encoders, some are made of decoders, some are made of both. And they can do lots of really, really cool things. And this is the transformer model. And so the way we do this is you take all the text that you have on the planet. It binds and uses a lot of computers. And so when it's very, very good at predicting the next word, it's kind of like the word predictor on your phone when you start typing and it tells you what the next word is. That's that model. It's pre-trained to predict the next word. Once we do that, we evaluate the model to understand how well it works. And if it works really well, we then do another set of training we call fine-tuning. And that set of training is when we take that model that can predict words and we get it to answer instructions. So instructions might summarize this bit of text. Instead of predicting the word, it actually summarizes it. Does it summarize it correctly? Maybe we will say, tell me about a story about a boy and a dog, and it generates a story. That is another instruction that we then teach it. Another instruction might be, here is a big story, tell me what the boy's name is, and so it can answer questions. So we go from pre-training, where it predicts the next word, to actually following instructions, asking questions. And that is fine-tuning. And today, you can actually take these big models and you can fine-tune it for your own purpose. Processing documents, doing whatever you want to do with it. So just to give you an idea, you can just go online and you can go pay a little bit of money, all free, and you can access GPT from OpenAI, you can access Claude from Anthropic, and you can just use these models because someone else has trained them for you. And so when we think about these models, I mentioned that we've got artificial intelligence as this big idea. Inside artificial intelligence, we have machine learning. Inside machine learning, we have neural networks. Those neural networks started with something called the perceptron. And so this was the first paper. And it was very, very interesting because when they came up with this idea of a perceptron, which mimics the neuron inside the human brain, and I urge you to take a photo and